Hello again, you sick, twisted weather freaks and snowstorm lovers. Welcome to another edition of the Snowstorm podcast for Wednesday evening, March 7th. The big second monster nor'easter of the month of March is winding down, but of course, over. It has come to an end in Philly and Jersey and New York, but it's still continuing across eastern portions of New England. Last I saw, Boston was still getting rain, but the snow is still coming down quite impressively over much of central and western Connecticut and central and western Massachusetts. So a lot to talk about here. Let's first we'll do a little bit on the current storm as it's winding down, and then we'll get into the potential significant event from March 11th to 12th, and why I'm dead bang certain that this event is coming and it's going to be significant. All right, we'll start out taking a look at the snowstorm matrix, and you can see here the only event we're talking about is going to be this event here for the interior Northeast, moderate snow, and then for I-95, a significant snowstorm, a real possibility here. I think this is the first one I've had for the I-95 all winter long. So we'll see if that works out. And then, of course, I want to take a look briefly at the radar here. This is the radar as of 1:30 this afternoon. Yeah, and you can see that the heavy snow is coming to an end now here. Yeah, 1:30 this afternoon. You can see that it's coming to an end right along this edge here, and the monster heavy snow bands pounding the area. And, Philadelphia did not get a lot of accumulating snow. Downtown New York City did not. Interestingly enough, southern New Jersey got a lot more snow in the rural areas than Philadelphia did. And that's because South Jersey got underneath these band, and the mesoscale feeder band, you can see it, the intense super band here of extremely heavy snow. Again, outside of New York City, but at one point it was covering much of southern New Jersey, central New Jersey in that line. Now you can see here at this slide, it's turned around to a bit of a cyclonic curve to it. And this is as of 4:30 this afternoon. The snow had now come to an end in Philly, and it's still snowing like hell over Jersey, central and northern New Jersey. And then finally, there was snow coming to an end over New York City. This was as around 7 p.m. this evening, and you can see it all coming to an end here. Now, one of the things about this storm, which is interesting, is that this is a type B, Millard B snowstorm. There are two different types of snowstorms. You probably don't know about this if you're a regular non-weather geek, but a lot of us do, so let me briefly go over this. This is the southern area of snow track. This is the southern low, where it comes up this way. So remember the January blizzard back into 2016? See, remember that storm? That was a southern snowstorm, okay? And remember the one that hit Norfolk and southeastern Virginia and northeastern North Carolina back on January 4th of this year? That was a southern snowstorm. They come up from the Gulf of Mexico. The other type of snowstorm is the one which is a bit more complicated. And what happens is that you have a primary low here, which develops, and a secondary low on the coast. And the primary low can often go up to Ohio, even western Pennsylvania, and then it jumps and reforms to the coast, and you get a big low here. So this is called the Millard B type of situation. And these are kind of tricky for a number of different reasons. Part of it is that when you have a Miller A snowstorm, the snowstorms are confined. You have a widespread area of big snow. So you'll have like 4 inches, and then 8 inches, and then 16 inches, and then so on and so forth. Okay, with Miller B's, you've got one area of snow here, another area of snow here, and in between you can have nothing going on. So that's part of the problem with the Miller B scenarios, and I'll show you what I mean here. Here's another example of how these storms develop, and you can see there's the primary low in Kentucky. See how it goes up into Ohio, almost over West Virginia, Pennsylvania. There's the secondary low, and then finally this low dies off, and you get the main low right here. Okay, that is the Miller B scenario. And the Gulf of Mexico low, you see there's no secondary low here. You have one big low here, it comes up the coast, so on and so forth. Okay. There are some other historic events in the background which have happened before, which are Miller B's. This snowstorm that we just had right now is clearly a Miller B. If you recall the maps of how the storm developed, you remember how the storm developed? We had a low coming in from Pennsylvania, and it jumped to the coast, and the secondary low developed over the Delmarva all day today, then moved up the Jersey coast, then turned east. Classic Miller B scenario. Okay. This was one from, some of you may remember this one, the December 2000 snowstorm at the end of the decade, end of millennial snowstorm as they call it. And you can see all the heavy snow here, this the light blue stuff is 10 to 20 inches, was confined in this area like this. Very little snow to the west, it dropped off dramatically. And this image on the left shows you specific snow plots. So in the this is out of Mount Holly, and you can see that there were areas in North Jersey had 25 inches of snow. New York City had around 14, 15 inches of snow. But look at the drop off here now. This is the New Jersey Pennsylvania state border. So by the time you got west, just outside of Allentown, the snow amounts were on 2, 3, 4 inches of snow, and then nothing over here. So 2 inches of snow here, a foot of snow here. That's a pretty intense gradient. And of course, if you look at the snow amounts, as we'll see back in here, we saw the same sort of thing. And here, again, very sharp cutoff to the western side. There's another example of that happening. This is the same snowstorm, but more detailed. This is December 2000, and you can see the very sharp, amazing cutoff between the super heavy snow and nothing. Okay. There are a couple other examples here. This is the February 1969 Lindsay Day snowstorm. And again, look at the very, very sharp cutoff in the snow on the western side of this sucker. Right along, New York City had 24 inches of snow in some places, but look at this, boom. Right along here, there was nothing. Nothing, 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 nothing. So, again, and then finally, one of the best cases of this is the February 1978 New England blizzard. Now, you can see the heavy snow here, but the line here is a little different. It had significant snow like this, out like this, and then so on and so forth. So, for example, Baltimore had 10 inches, Northeast Maryland had 16 inches, DC had 1. Yeah, DC had 1. There you go. Pretty impressive snow cutoff right there on the February 78 snowstorm. So there you go. And this is just a really great radar image here that shows in central Jersey where the heavy snow band was coming in. Let me call it up here. You can see that's what this was here. And if you scroll down, there you go. You can see the heavy stuff. That's Hamilton and Vineland, New Jersey. You can see a very heavy super monster snow band right here. Usually you don't see, a radar signature with that sort of intensity snow band. It just doesn't happen. I've never seen that before. And this is somebody in central New Jersey reporting huge amounts of snow. And also from Weather Nation here, you can see the snow amounts, very impressive. This is, Essex is only 15, 18 miles west of New York City. And you can see the huge difference in the snows between New York City, which only had a couple of inches, in downtown areas, and then just to the west and just to the north. This is northwest New Jersey. Look at this stuff. Holy cow. And here's Connecticut, where some of it's still snowing, as you can see. So very impressive. All right, let's get on to our next system here. So let's talk about February 11th to 12th. So here is the blocking pattern. This is the huge block, the negative NAO, the west-based negative NAO. And here is the current low, which will be up there to tomorrow morning. And there's another piece of energy right here. What's going to happen is this is going to capture this into one big system. And you'll see that 1 second. There it is. Both systems submerged into a large, as you can see here, upper low in the jet stream, very large upper low over New England, very cold pattern for this time of year. And here's our blocking feature. So this sort of configuration is known as a Rex block. And you can see it more carefully. It's like an omega block, except it's vertical. So the omega block is shaped like the letter omega, as we know. Okay, so there's your high in your jet stream. There's your trough here and a trough here. With a Rex block, it's where you have a low here, the high here, and a low here. Well, that's exactly what we have here. There's an upper low here, there's an upper low here, and there's your ridge of high pressure right there. So this is a Rex block pattern. And as a result, it's very important, and you have to keep that in mind. Weather models which screw this up are going to have problems with the track of the March 11th, March 12th East Coast winter storm. Now here comes the feature. This is Saturday morning. There's our blocking feature, still very pronounced. And there's the low underneath it. There's a Rex block right here. Now this is the main piece of energy which is going to swing down through underneath it. and then we can take a look at it here, 99 hours and 120 hours. So this piece of energy is now right here. You can see it. Look at the Rex block, very clearly seen. All right, low here, and here's the high. Monster Rex block. So this is a powerful piece of energy, swings down through here, and it has to go underneath it. And because this feature is still here, this can only get so far north. This low, wherever it develops, can only go so far north because of this configuration. That's the important point here. Models be damned, this is basic laws of physics. All right? It will be the intensity and the shape of the megaridge, the block, which will determine, that should be how, sorry about that, how far northeast or east northeast or even east the Carolina low will track. It will be the block which will determine it. This block here. That configuration right there. Okay? All right, good. So now this was the European model from early Wednesday morning. This was 0Z Wednesday. Okay, and you can see the low is here. All the precipitation is south of the Virginia-North Carolina border. All right, looks like it's out to sea. But again, if you look at the European ensemble, this is from early Wednesday morning. Notice the two features. This is the current storm. It is now over here by March 11th, March 12th. Okay, so the low which is here goes to here. Now, this is the next system coming up from March 11th, 12th. There it is. Okay, because of this feature here, this cannot go north up the coast. That's out of the question. It has to take this sort of track. It has to. Basic laws of physics. Now, if for any reason these models are wrong and you don't have that huge low south of Newfoundland, Canada over here, let's assume that for a second, let's just say, okay, let's spitball this. Suppose this feature isn't here. Then the low can come up the coast. Okay, but as long as that feature is there, it can't happen. Can't. Models be damned, can't happen. Here's the European ensemble, early Wednesday morning. Again, this is the 0Z run of the European ensemble, and there's the low. And the rain snow line is right through Richmond, and you got snow up to DC, Charlottesville into central West Virginia, Roanoke, everybody. Baltimore, Fredericksburg, the Northern Neck, St. Mary's, the Delmarva. Yeah, baby, party on. Okay, party on, Garth. And this is the early morning GFS. Again, this is the 0Z run of the GFS. Okay, and you can see now, obviously it starts off as rain, and the big snow, the wedge here in the Shenandoah Valley. That's good, but notice as the low goes to the east, the snow comes closer to Richmond and 95 and gets up towards DC. Okay, that's great. And then if we go to the next frame, this is Monday morning. Now it's snowing in Richmond. It's still raining in all of eastern North Carolina and Hampton Roads, maybe into the Delmarva. But the low moves off the coast, and you can see now the snow gets up to DC. It is too early to know whether or not the snow is going to get to DC or not. This is the GFS. I think the European is correct. I think the snow is going to get up towards Philly. I mean, up towards DC and Hagerstown and Baltimore and Wilmington. Maybe it's Philly and into southern New Jersey. I think that's very, very likely to happen in these sort of scenarios. Okay, now this was the early morning GFS. Let me clear this out. Excuse me, this was the British model. This is the 0Z British model. Okay, the 0Z Wednesday morning British model. Now, the other important feature is it also has this big low here, the 50-50 low. Okay, it's part of the Rex block. So the low is here, and as a result, it's forced to stay off the coast. It cannot come up the coast. Okay, this is a classic, great-looking snowstorm pattern for the East Coast. I mean, that's just screaming bombs away. And here's the track. I mean, look at that track. That is a classic track for a Philly to Richmond and into the Shenandoah Valley in Maryland and West Virginia big snowstorm. Classic track, New Jersey as well. This also provides moderate snow into New York City and to southeast of New England, yes. The big snow in this sort of track would be Virginia, maybe far west of North Carolina, a good portion of Virginia, again, not Hampton Roads, but everybody else, eastern West Virginia, Maryland, Delaware, like I said, the southeastern Pennsylvania and southern New Jersey. So that's very bullish. Now, this is the 12Z GFS. Notice it's got the low up here and then takes it up towards Cape Cod. Now that's a good snowstorm for everybody in Virginia except for Hampton Roads. Notice the heavy snow in D.C., in Philly, Baltimore, southern Pennsylvania, maybe as far northwest as Pittsburgh, West Virginia, and then it's off to Cape Cod. Good snowstorm for everybody. Viable scenario. The problem is this. Let me show you what the problem is here. Okay, remember we talked about that omega block. The GFS has it. This is today's storm. Today's storm. Okay, March 7th. Now that's where it is. It goes up to Canada. It's part of the omega block. You see the omega block feature? There it is. Just like I highlighted. There's the low. The problem is when you get to the weekend, the GFS weakens the omega block. This is bullshit. This is wrong. Okay, it's the GFS. What do you expect? And if you take a look at the GFS ensemble, we compare the two. Here we go. Okay, this is the operational GFS. Now this is the 12Z run from today, and this is valid for 1 o'clock Monday morning. There's the low on the Delmarva coast. Heavy snow to Philly, Baltimore, D.C., Fredericksburg, Charlottesville, the entire Shenandoah Valley. But look where the low is on the ensemble mean. Significantly further to the south. Why? Because the GFS is not screwing up the pattern over eastern Canada. All right? Like I've been saying here, it will be the intensity, position, shape of the omega block that will determine how far northeast, east-northeast, or east the Carolina low on March 10-11 is going to track. So because the GFS screws it up, it comes too far north, as you can see. And then if you look at the ensemble mean, it's much closer towards the European. This is the 12Z European model. Okay, let's take a look at this. This is 12Z Wednesday. Okay, big snowstorm potential here for a good portion of central and northern Virginia. Now the purple line, that is the rain snow line, approximately. All right, so this is Sunday afternoon, 1 p.m. Atlanta's got rain. This is all rain down here. This is all rain. But you can see the purple line here. So Raleigh, Lynchburg, the Shenandoah Valley, that's all snow. On the edge in Richmond, okay, 7 o'clock in the evening. Now the sun's going down, so that's when we get our best snows. So the rain snow line is right over Richmond. Charlottesville snow, Roanoke snow, Lynchburg snow, Hot Springs, Beckley snow, DC snow, Fredericksburg snow, Northern Neck, Richmond right on the area, as you can see that. And then if you go beyond that, oops, let me clear this out. Now this is the European ensemble for Sunday night. Ensemble mean, which is, remember, this is 50 models taken as an average. So you get a much better result. This here is your approximate rain snow line. As you can see, it's right over Richmond, but south of Roanoke. Again, DC's all snows up to the Pennsylvania-Maryland border. And this is 1 a.m. on Monday morning, March 12th. And again, here's the rain snow line. It's now south of Richmond, and you still have significant snow all the way back in here. So yes, this is a very bullish looking map if you like snowstorms in March. If you look at the ensemble mean, again, here we are. It's not changing. This is the big storm, today's big storm, south of Newfoundland, Canada, blocking this system from coming up the coast. It cannot do this. So it's got to do this. And that is a great track for Virginia, Maryland, Delaware, southern New Jersey, southern Pennsylvania, so on and so forth. Okay. This is the British model, the new updated one, 12Z of the British model. Okay, so this is 12Z Wednesday. Got it? Look where the low is. Ooh, this is a southern low. Remember that Miller A we talked about, the southern low? There you go, baby, according to the British model. And we also have the block here. Again, you can see it right here. There's the 500 low right here. Okay, so that's your 50-50 low, which is part of the Omega Ridge. Great looking map, great looking snowstorm map here on the British model. And what does the British model do? Now, the UK British model does this. I've plotted the red dots here, here, and low pressure areas in here. Now this is a blizzard. I don't know how else to say this. This is an East Coast blizzard if the British model is right. This is the 12Z Wednesday British model. This is, and you look at the dates, March 12, 13, this is a historic snowstorm, according to the British model. I mean, it's just bonkers. Everybody would see snow. Richmond, Pittsburgh, Charlottesville, Boston, everybody. Albany, it's a big freaking deal. This is right. This is a historic snowstorm. Now, none of the other data at this point is showing that, but keep it in mind. Okay, this is the afternoon GFS, the 18Z run, and you can see the 18Z run here versus the 12Z run here. Remember, they got the low over the Delmarva? See the Chesapeake Bay? Look where it is now here. Southeastern, far eastern, central North Carolina. Big difference. Why? Because the 18Z one now sees the blocking pattern over Canada, and here, as we talked about, it did not. So as a result, the low shifted to the southeast. Bada boom, bada bing. And by the way, that matches the European scenario very nicely. So, in summary, Southeast Virginia, all of central and eastern North Carolina rain. Western North Carolina, maybe. If the low stays far enough south, the western third of North Carolina, especially the northwest, has a chance for seeing accumulating wet snow. Yes, it has been a while since the Shenandoah Valley, Northern Virginia, D.C., Baltimore, Central Maryland has been hit with a good snowstorm. So what? It doesn't matter. It does not matter, folks. It just doesn't. Okay? If you're simply saying that because it hasn't happened recently, it can't happen, I don't want to hear that because that's not science. That's just superstitious nonsense. Okay. Odds strongly favor all these areas with at least 4 inches of snow or more. Could be a lot more. Again, Northern Virginia, D.C., Baltimore, the Shenandoah Valley, Northern Virginia, Piedmont, all that area. The snow ratios are going to be an issue east of the mountains. They always are in March storms. That's just going to be one of those things. That means if the model is giving you 8 inches of snow or 10 inches of snow at 10-to-1 ratio, it may not be that. Okay. March snowstorms always see the best accumulations at night. This main event is going to be the Sunday night into the morning of the 12th. One of the reasons why this could be a significant snowfall. And finally, again, the position and shape of the Omega block will make this an easy forecast in that the event is going to occur. I'm not telling you I know where the rain snow line is going to show up exactly at this point. I'm not telling you who's going to see the heaviest snow, but the event is coming. No doubt about it. And finally, yeah, baby, snow dog for March. There you go. Meteorologist DT from weatherrisk.com, and I'll be talking to you soon and on the Facebook page, on the Twitter page.